This is Section 5, Descriptive Correlational Inferential Statistics in Making Sense of Statistics, 6th edition. So, descriptive statistics summarize data. So, let's say you have scores on a standardized test for 500 participants. You could calculate an average score indicating how the typical individual scored, which is one way to summarize the data. You could also determine the range of scores from the highest to lowest, which would indicate how much the scores vary. Descriptive statistics are detailed in Part B of the textbook. So, correlational statistics are a special subgroup of descriptive statistics. They describe the relationship between two or more variables for one group of participants. Their purpose is to describe the relationship. Now, the correlational statistics are described in Part C of the textbook. So let's suppose a researcher is interested in the predictive validity. Now, correlational coefficients range in value from a 0.00, which shows no correlation or no relationship between the variables, to a 1.00, which is a perfect correlation, which means there is a perfect relationship between the two variables. And the meaning of these values are described in Part C of our textbook. So, inferential statistics are tools that tell us how much confidence we have when we are generalizing from a sample to a population. A percentage is a descriptive statistic, but a margin of error is an inferential statistic. So consider national opinion polls in which carefully drawn samples of only about 1,500 adults are used to estimate the opinions of the entire adult population of the United States. So the pollster first calculates descriptive statistics such as the percentage of respondents in favor of the capital punishment and the percentage opposed. So having sampled, a researcher knows the results may not be. So when we're talking about the margin of error, let's just look at that a newspaper might have reported that 52% of the respondents in a national poll believed the economy was improving. Now, if we look at a footnote in the poll, it might indicate the margin of error was a plus or minus 2.3. So really what this means is the pollster was confident that the true percentage for the whole population was within 2.3 percentage points of 52%, which then makes that percentage range anywhere from 49.7% to 54.3%. So when we're talking about populations, we could talk about a large population, and a large population of interest might be all adults over the age of 18 who reside in the United States. So if we're looking at this right now, we might have over 245 plus million adults over the age of 18 who reside in the U.S. Now we can also look at a small population, and we could say it's all nurses who work in a specific hospital. So what that means is it might not be all of the nurses in the city or the state or the county, but it might be the population just being small as all nurses who work in a specific hospital. When we're talking about a census is all members of the population are included, and this is called a census. A census is feasible and desirable when studying small populations. So, for example, a professor may choose to pretest all students at the beginning of a course. Inferential statistics are not needed when analyzing the results of a census because there is no sampling error. The use of inferential statistics for evaluating the result when sampling has been used is covered in Part D of this book. Some of the endnotes: correlational coefficients can also be negative. Negative coefficients are described in Part C of the book. The word inferential comes from infer. When we generalize from a sample to a population, we are inferring that the sample is representative of the population.